Hello students, my name is Shashank Shekhar. So let us continue with the exercise of a structure of atom. So the first question says that calculate the wavelength of the emission of transition or the emission transition if it starts from the orbit having radius this much and ends at this much. Name the series to which this transition belongs and the region of spectrum. Now what is said in this question? It is said that we are given two radius, okay, two Bohr radius. Now we have to calculate that if a photon is emitted from during transition between these two radius, then what is the wavelength of that emission, and also we have to find that to which series that transition belongs and the region of spectrum that is related to that series. Clear? So for that, first we will find the related quantum number with the given, or the related principal quantum number with the given radius, right? So these are the two radius. So what the formula for calculating the radius? We know that for nth radius, the formula is 0.529 z square by n square by z angstrom. So it is given in nanometer. We will convert it into angstrom. That would give us 1.3225 into 10 to the power. So nanometer to angstrom is -1. Clear? Next is 21.6 picometer. So nanometer is smaller than angstrom, right? Nanometer is smaller than, is bigger than angstrom. So multiplied by +1. In this case, it is given in picometer. We have to convert it into angstrom. That is 10 to the power 2 angstrom. So this is this much and this is this much. Clear? Okay. So that would be 10 to the power -1. Now we will calculate the radius. Sorry, calculate the n for the both of this value. So that would give us 1.322, or we can write it as 0.13225 is equals to 0.529 n square by z. So what would the value of z here? So suppose we are taking for hydrogen. Calculate the wavelength for transition if the starting orbit is this one. Yeah. So that would give us 0.133225 by 0.529 root under. Okay. So that would give us one of the radius. Now we can calculate the second radius from this. So that would give us root under 0.529 n square. That would be 1160 by 0.529. Okay, so we'll calculate the value of n for both of this. So see, we have done the similar thing here. So for radius 1, this is the value. So if you just do the same thing, that would give us 6.25, right? So that would give us this value, and n1 square is this one, and n2 square is this one, right? Now next, what we have to find? We have to find the wavelength related if the transition takes place from n1 to n2. So how we will do it? So for that, what they have done is they have taken the ratio of n1 to n2 and used it directly in the formula. So this ratio comes out to be 5:2, and that is 5 and 2. So n1 is 5 and n2 is 2. No problem. Okay, so we know the formula that in terms of wave number, this formula is 1.0979 into 10 to the power 7, 1 by n1 square, sorry, 1 by n2 square minus 1 by n1 square. So the transition is taking place from fifth orbit to second orbit. Okay. So we have taken 1 by 2 square minus 1 by 5 square. So that would give us the wavelength as 2.303 into 10 to the power 6. So if you know then the series that is related from for transition that is ending with the second orbit is Balmer. Okay, so they have calculated the lambda here first of all. So that was for frequency. So they have calculated the lambda that would give us 434 nanometer. So that is falling in the Balmer because the transition is taking place to the n is equals to 2, right? So Balmer series. Now, if I ask you that in which spectrum does this fall, means Balmer series is of which spectrum? So what would be the answer? So it falls in visible region. Clear? That falls in visible region. So let us move to the next question. What does the next question says? The next question says that dual behavior of matter was proposed by de Broglie. We know that, and he gave the relation to relate the velocity of the same with the wavelength, that is lambda is equals to h by mv. Next is uh, if the velocity of the electron in its microscope is this much, this is the velocity, we have to calculate the de Broglie wavelength. So very simple question. So one piece of information is also given here, that this de Broglie relation relate to the discovery of electron microscope, which is very precise microscope that is often used for highly magnified images of biological molecules and other type of materials. So this is very important. So how it is measured? So suppose we have a system here that is containing a biological molecule. Any biological molecule can be there. Suppose a protein molecule, say of heme molecule of say iron. And what did they do? They took an electron and attack that system or the protein, or the throw that electron on that system, and there is a detector that receives that electron, right? Now what did they do later on? They just calculated the velocity initial and final, and once the velocity is calculated, then they use that velocity to calculate the wavelength associated with the electron, the change in wavelength. Okay, so with the help of that wavelength change, they created a imaging of that given molecule, right? So this is a very interesting application of the de Broglie wavelength, that is the electron microscope, that is highly accurate in nature, and that is used for say getting the images of biological molecules, which is very important for making say medicines and all, because you need to find the target area where the say medicine has to work in the given protein. Okay, so this is very important. Clear? Let us coming back to the question. The question says that we have to calculate the velocity, and velocity is given, we have to calculate the wavelength. So the formula is simple. The formula says that lambda is equals to h by mv, and lambda is to be calculated. H we know, that is the Planck's constant, 6.626 into 10 to the power minus 34. So you can take 6.6 into 10 to the power minus 34 also, until and unless it is not mentioned in the question or say in the booklet that you are given to solve, right? So until and unless it is not mentioned, you can take both of these values. Next is the mass. What is the mass of an electron? 9.1 into 10 to the power minus 31 kgs. Okay. Next is the velocity, that is 1.6 into 10 to the power 6 meter per second. Now all your units should be in SI unit, because it is not mentioned that you have to calculate wavelength in which unit. So we are taking the SI units here. So we know that the Planck's constant SI unit is joule second. For mass it is kg, and for say this velocity is meter per second. We can try to just cancel out these units to get the derived unit of lambda, and that would be very helpful in say inspecting a formula, right? But that would not be accurate inspection. But still, if you are confused that what is the formula, then you can do the dimensional analysis and just cut off the units to get the final unit, right? And we know that the unit of wavelength is meter, because it is a unit of length, right? So if you cancel out all of this and you get finally the unit as meter, then your formula is correct in a way. I am not giving a accurate information that it would be correct, but still it would give you idea. Clear? Now coming to the solution. So we have lambda is equals to hm by mv. So the values are put here: 6.626 into 10 to the power minus 34, 9.10939. So very accurate values are taken here up to say 5 decimals. You can take up to 9.1 also. There is no problem in it until and unless it is not mentioned in question, right? So this is the mass and the velocity is given. So after calculation, we got this 10 to the power minus 10. So convert it into scientific notation always, right? So that is a more appropriate way to write these things. Okay. Now further, if you move the decimal place to the right, then the value will increase. That is 10 to the power minus 12. So 10 plus minus 2. Yeah, here. So that would give us 455 into 10 to the power minus 12. And we know that the relation between 1 meter and picometer is nothing but 1 meter is equals to 10 to the power minus 12 picometer. So if you convert it into picometer, that would give us the value of lambda as 455 picometer. Clear? Next, what does the next question says? So similar to the electron diffraction, neutron diffraction microscope is also used for the determination of structure of molecule. So we can take neutron also, although a neutron is not taken often because you know that electron has a very light mass. Okay, it is very lighter as compared to your neutron and proton. So if something is having a heavy mass, then that would be not appropriate for a given structure, or say it is not applicable everywhere, but still neutron microscope are also used. Now if the wavelength that is used for the neutron, the wavelength that is used is 800 picometer, we have to calculate the characteristic velocity that is associated with this wavelength, that is 800 picometer. Again, we will use the formula lambda is equals to h by mv. But here what we have to calculate? We have to calculate the velocity. Okay. So here they have calculated, rather than velocity, they have taken v. Yeah, it is correct. So let us put all these values: 6.626 into 10 to the power minus 34. And the mass of a neutron is 1.67493 into 10 to the power minus 27. So that is the thing to remember. Next is the wavelength associated with it. So we have converted this wavelength, which was given in picometer, to meter by multiplying by 10 to the power minus 12. So that would give us a value of 4.94 into 10 to the power 2 meter per second. So this is wrongly written. Yeah. So this is the value of velocity. Next question. If the velocity of the electron in Bohr's orbit is 2.19 into 10 to the power 6, calculate the de Broglie wavelength associated with it. So the velocity is given, and again we have to calculate the de Broglie wavelength. So how you will calculate? Very simple. Use the formula again. Put the value of velocity. H and M are fixed for a given electron. That would give us 332 picometer. The velocity associated with a proton in a potential difference is this much. So this is the velocity given. Now if the hockey ball of mass 0.1 kg is moving with this velocity, means which velocity? This velocity, then calculate the wavelength. So in this case, we have to calculate it for a given hockey ball. The velocity is given, the mass of the hockey ball is given. You have to calculate the wavelength. So again, we will use the formula lambda is equals to h, that is 6.626 into 10 to the power minus 34 by mv. Mass is 0.1 and velocity is 4.37 into 10 to the power 5. No problem up till this point. Now you will just calculate this value to get the value of lambda. So do not get confused with this value that is given. So it is of no use in this question. It is just mentioned that to keep the velocity as at this much, we have taken a voltage of 1000 V. Next question, what does the next question says? So if the position of electron is measured in an accuracy of 0.002 nanometer, so what it is written? It is written that we are given the uncertainty in position. So delta x is given actually 0.002 into 10 to the power minus 9. So I'm converting this nanometer into meter. And the next thing that is given is to calculate the uncertainty momentum, that is lambda p, sorry, delta p. We have to calculate delta p, and the momentum of electron is, suppose we have to find it in this way, in this form. So how I will calculate? So we will put the we'll take the formula first of all, that is delta x into delta p is equals to h by 4 pi. In some places this can also be written as h cut by 2 pi, so do not get confused. So it is nothing but h by, okay, h cut by 2. Oh yeah, so h cut is nothing but h by 2 pi, right? So if you put the value of h cut here, that would give you h by 4 pi. Now the value of, say, position is given, the value of h Planck's constant is given, and you will put all these values to get the value of delta p. So this is 4, this is pi, the value of pi is 3.14. So that would give us the value of delta p as this much. So this is nothing but say your uncertainty in momentum. Now it is given that the uncertainty in momentum is this much. So the actual momentum would be how much? It would be h by this much. That would give us a final value of this much. Clear? Next is, so did you get my point? So in the question, it was also given that the actual momentum was this much, right? And so actual velocity was this one, mass into velocity was this much, and we just use this. So this is the value, lambda is equals to h by mv. So lambda was given, and what we did is we calculated the actual momentum. That would give us this much value. What does the next question says? The next question says the quantum number of 6 electrons are given below. Arrange them in the order of increasing energies if this combination have the same energy list. So what we have to do, we have to just say arrange them in the increasing order of energy. So for 6 electrons, 6 quantum numbers are given. So how you will do it? Simply you have to calculate the value of n plus l. So let us calculate it for all. So for this it is 6, for this it is 5, it is again 5, 5, 4, 4 plus 1, 5. Now once we got these values, so the one with the smaller value of n plus l will be lesser in energy. So if I take this number as the notation for this, say, configuration, so the one with the least value of 4 is fifth. Now 2, 3, 4 and 6 all have the same values of n plus l, and the last one is 1. Now what about this 4? So for these 4 we will see the value of n. So the one with the lesser value of n will be lesser in energy. So let us see. So for 2 the value of n is 3, so that would give us 3 first, and here 2 and 4 have the same value of n, and similarly 4 and 6 have the same value of n. Now we come to this conclusion. Now what are we left with? We are left with the value of ml. So let us compare the values of ml. So for 3 and 4, 3, sorry, this would not be 3 and 4. So 2 and 4 are equal, and your 3 and 6 are equal. Yeah. For 2 and 4, n plus l value is same. Value of n and l are individually same. So we are left with the value of ml, right? Similarly, for these 3 and 6, the value of ml is also same, right? Value of ml is also same. The value of ms is changed. No, it is also same. So how you will just justify this? Okay. So if you remember, there is a splitting of all of this ml in the presence of a magnetic field. But here, there is no such statement made. So therefore, first of all, 3 and 4 will have the same values, same energy. Okay. Similarly, 2 and 5 will have the, sorry, 2 and 4 will have the same energy. So therefore, we can say that ranking this orbit in this order. So therefore, the question was asked that if any of this combination have the same energy list, we have to say, okay. So 2 and 4 will have the same energy, and 3 and 6 will have the same energy. ML will not affect it. If we talk about order, so this is the order. Okay. So for fifth, it is 3s. For 2 and 4, it is 3d. For 3 and 6, it is 4s. And for 1, it is 4p. So 3s, 3d, 4s, 4p. Sorry, that will be p. 3p, 3d, 4p, 4d. So why it is, I'm writing it wrong, because value of L is 1, so it will be P, and value of L, if it is 2, it is D. Okay. Next is, the bromine atom possesses 35 electrons. It contains 6 electrons in 2p and 6 electrons in 3p and 5 electrons in 4p. Which of these electrons experience the lowest effective nuclear charge? So it is very simple. The 4p present on the outermost, so it will experience the least effective nuclear charge. So the nuclear charge is the experience by electron, and why it is least by this 4p? Because of the shielding effect. So the greater is the distance, the lower is the effective nuclear charge. Among p orbital, the 4p orbital are the farthest from the nucleus. Hence, the electron that reside in the 4p orbital are those that will experience the least effective nuclear charge. These electrons are also shielded by the electron that are present by 2p and 3p. Among the following pair of molecule, which will experience the larger effective nuclear charge? So 2s and 3s. So which will experience? So the one with the greater value of n will experience the greater nuclear charge. Sorry, smaller value of n will experience the greater effective nuclear charge. So in this case, 2s will experience. Now what about 4d and 4f? So they both are having the same value of say n. So now we will calculate say compare the value of L. The one with the least value of L will experience a greater effective nuclear charge. So this will experience greater effective nuclear charge. Similarly, for this 3p will experience a greater effective nuclear charge. So it is written same. The electron that resides in 2s will are closer to the nucleus than 3s, therefore will experience greater nuclear charge. Here also 4d orbital are closer, so therefore 4f will be on the farthest one, and hence 4d will experience greater nuclear charge. Here also 3p will experience greater nuclear charge. Clear? Next question. The unpaired electron in ammonium and silicon are present in 3p orbital. Which electron will experience more effective nuclear charge? So it is asked that among the electrons of ammonium and silicon, which one will experience greater say effective nuclear charge? For that, you have to see that which orbit is containing a greater number of electrons. Since this 3p say 3p of ammonium will contain 3 electrons, sorry, 1 electron, and your silicon, 3p of silicon, which is for aluminum, this is for silicon. This contains 2 electrons. Therefore, this will experience less effective nuclear charge and this will experience greater effective nuclear charge. So the answer is aluminium. So it is written also. Since silicon holds 14 protons. Oh, sorry. Next, indicate the number of unpaired electron. Okay, you have to indicate the number of unpaired electrons. So for that, we will write the electronic configuration. So for phosphorus, 1s2, 2s2, 2p6, 3s2, 3p3. So number of unpaired electron is 3. Next is silicon. It will have 1s2, 2s2, 2p6, 3s2, 3p2. So 2 unpaired electrons. Iron is 26. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So how many unpaired electron? So if you just feel this one, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. That would give us 4 unpaired electron. Next is krypton. So in krypton, all the electrons are paired up. Okay. So therefore, it will contain no unpaired electron. In this question, we have to calculate the number of subshells associated with n is equals to 4. So the formula is simple. That would n square. Okay. Subshell we have to calculate, not the orbital. So that would be not n square. That would be n minus 1. Okay. So 4 will contain S, P, and D and F. That would contain 4 types. Right? N is equals to 4. If you want to calculate the number of orbitals, that is n square. Okay. So n 4 4 just 16. Now it was asked that the ms value of if each orbital has 1 electron, therefore if a is so, therefore the number of electrons which will have minus half value will be 16. So you can do it in this way also. Suppose there is nth orbit, so the number of electrons is 2n square. Okay. Now out of this, half will be plus half and half will be minus half to validate the Pauli's laws of exclusion principle. That would give us n square. So 4 4 just 16 is the correct answer. Clear? So this was for today's lecture. So hence we have completed all the exercise of structure of atom. Okay. Now with this I end my lecture. Thank you.